RAG pipeline, right? Which, as we know, means pulling data from an outside source, load it into a database. Someone submits and embed it. Someone submits a query. We embed the query. We find do some sort of similarity score, if it's cosine similarity or something similar, to retrieve the most relevant documents or the most similar documents. Those documents or the chunks, those become our context that then we ask the question with the relevant information, right? Feed that to the LLM, which submits back a response to the user. So far, what we've focused on is this loading stage, all right, and there are kind of like two different components to it. One is actually reading in the data, and remember there are different kinds of readers that we can use. We saw that, right? Just like the simple directory reader is one of them. There's an HTML reader, etc. Another kind of tool that Llama Index gives us, and by the way, it also says, Llama Hub provides lots of different examples. So, this is a big library. So you can see, part of it is navigating the library, right? So EPUB reader, I'm guessing is for navigating like ebooks. This is kind of interesting. IPYNB reader is probably for reading in Jupyter notebooks more easily, right? So this is one kind of stage, but it's useful, and there's all these different tools, but it's useful just to organize, structure this information in your brain. So, one component is loading the data. There's different readers for that. The other component of that is parsing the data, right? So there's HTML parsers. We saw, the one that we directly used is this this sentence splitter, right? But then there are other ones that I linked to that you can explore. So that's reading the data. The next stage is then indexing it, right? And it says, okay, this is creating a data structure that allows for querying the data. This means, this nearly always means, creating vector embeddings as well as other metadata strategies to make it easy to find contextually relevant data. So we can get into that a little bit. And then the next thing is then querying the data. So there's multiple ways that you can query the data. And we can, there's a couple lessons on that too. And then finally, so that's what you can kind of see that we'll be doing today is one, indexing it, and then we'll get into querying it. And then from there, Streamlit. And then actually in this last lesson, what I put in some resources on both, say you want to use a SQL query to say filter, the top restaurants in a given neighborhood. Maybe, if we load in data from Foursquare, only over 4 stars in this zip code. And then from there, maybe you just select those relevant documents. And then you have, the LLM summarize it, something like that. How do you do something like that? I put in some resources for that kind of approach. All right. Let's get into... So far we covered loading. We can get into indexing the data now for just a little bit. 1 second. All right, so again with indexing the data, that means how do we actually, store the data and when we retrieve it, how do we store it in such a way that it potentially makes it easier to retrieve? So, with Llama Index, there's different kind of indexing strategies. The one that we've used so far is this vector store index. This is very simple. All it does literally is it just stores the data successively. And if you look at it, which we'll do, you'll see that it's just, literally a list of documents. But there are other ways of storing the data. One example is keyword index. So, we'll see this in a second. In Llama Index, it's called keyword table index. So what happens here? When you submit a query, let's say, for this one, it asks about New York City. And let's say, we read in a bunch of data, the Wikipedia article on New York City. And then we ask, okay, how large is New York? Or, how many immigrants are there in New York City, right? So the first thing that it might do when you submit that query is first generate keywords from that query, right? Like population, NYC. Then when we have loaded the data, it will also have generated keywords associated with each one of those chunks or each one of those nodes, right? So what it will do is, instead of going through all of the chunks in our database, it will first tag each of them with keywords and then only search through the ones that have a matching keyword. What's the benefit of this? Well, it's faster because you don't have to look through everything. What's the cost of this? Well, if you don't match that keyword, you can miss something, right? So, for like sometimes when you have a lot of data, maybe that makes sense, but it doesn't have the exact comprehensive match that a vector store index would have. Another approach that we'll see in a second is a tree index. A tree index is kind of interesting. What it does is it first takes all of the nodes. I call these the source nodes, right? So this is your original document. And then what it will do is it will, organize them, I guess probably based on some sort of similarity. And then it will produce a parent node. So these bottom level nodes, they're from your original document. These nodes are not. These are generated by ChatGPT or your LLM. And what these do are this is like a paragraph summarizing these other nodes. Okay? So, if I like in our example in the code base that you'll see, it talks about like the tech sector globally, right? So you can imagine that maybe there's things on like the tech sector in Asia and the tech sector in South America. And then this parent node says, hey, the tech sector in South America is growing, particularly, Argentina and Brazil and blah, blah. And so then when we ask a question about the tech sector in South America, first it computes similarity scores against the summary nodes, finds the most similar ones, one or ones. Then if this matches, because it says, hey, this talks about the tech sector in Latin America, then it will only search those nodes that match. Okay? So these summaries are derived from the source nodes. It looks for the most relevant summary nodes and then goes to the related nodes of the summary text. All right? So let's see this. What you can see is, I read in the data that comes from this global fintech report that I downloaded. We say, I don't even think we need this. This is OpenAI embedding. I guess I passed through the API key, but I don't think I need that. Then you can see I'm trying out different kinds of indexes. So this is the vector store index. This is the keyword table index. That's the keyword index that we saw above. And then this one is the tree index that we see here. All right, so let's take a look at it. If we type in vector store index, this is the vector store index. Then we can do .index struct. And you can see this is what I mean. It's very similar. It's very simple. This index here literally just stores the documents successively. So this node dictionary, this is my node ID, and this is like the chunk, that represents that the document was chunked up into. So for example, what we could do, if you want to see this, right, you can do like, here's the vector store index the vector store index doc store. Okay. And that returns actually where the document is stored. And then we can do .docs, and that will be all the docs. You can see that. This is like all enormous amount of text, all the docs. But really what we care about is, I think we can just do this. Shoot, I typed in the wrong thing. Doc store. Let's get an ID one more time. So vector store index struct. This will give me the document IDs, and let's say you want to see one of them or see how this is retrieved. You can do vector store index.doc store .docs and then plug in, I think, this one. Did I break it? Oh, I just have an extra quotation mark here. Okay. So this is, the vector store index just stores the IDs, and then the doc store actually has, the text. Okay. So this is like the first chunk, right? It just has like, I guess, the title and things like that. Right, and it has these different things, the page label. This is kind of interesting, right, that it did generate all this metadata for us. Let's see. So this will become more interesting if we start to see what the keyword index looks like. Let's take a look at this one. So here we have the keyword index dot index struct. So notice this one's different, right? This returns a keyword table index. And then if you look at the table, it's generated, right, keywords. And then for each one of the keywords, it has a corresponding part of the document. Okay. One thing that I think is interesting here is like you kind of see like all the extra stuff that we probably didn't really need. It shows the importance of probably, actually doing some engineering to maybe only feed into our database, right, the relevant documents, right? Like these are just people's names. Probably like the authors of the report or things like that. We really didn't need that, in this case. So like we could have done some engineering up front to maybe just select certain pages. But then you can start to see like now we're starting to get into some documents, right? So what you can imagine happening is, the query comes in, it says the word currency, and then we look for, and now we select those documents that have the word that are tagged with that word currency. Okay. So again, same thing. You can just go to the doc store, right? .docs, and then just select that with those that have that tag. It will give you the ID from the index struct, and then once you have that ID, you can just select the relevant docs from the docs store. All right. So this is like keyword indexing. Again, right, it's faster, but as you can see, right, like you can maybe potentially miss some data. Now the last one is this tree index, right? And again, like I didn't. It was hard for me to figure out how these worked. So it wasn't until I did this kind of digging that I could see, like, kind of get a sense of what these actually do. Like the documentation and even people's understanding, like if you read tutorials, they're not always exactly right. Like the truth lies in just looking at stuff. So let's look at this tree index dot index struct. Okay, so here you can see this is different, right? Now the keys are, we have, these are just the original, it says all the nodes, and then there's going to be some children nodes. So, for example, these maybe are just like, some original nodes, but then later on you can see that this is a parent node that then has various children nodes, right? So when you do a search, first it would search against the parent node, see the match, and then if they're, the most similar parent nodes will point to some of the original source nodes. You can do the same thing. You can look at these parent nodes. These are just stored in your database too, right? And for me, what I did was I was like, okay, let's look at this thing. Here's the tree index.docstore.docs, right? And then just select that. Let's look at the parent node. Right, and now here you can see this is the summary text. The report, Global FinTech 2023, Reimagining the Future, discusses the evolution and impact of fintech companies on financial industry. It highlights key statistics. So you can see this is generated text, right? Like it's not in our original document, right? And then there are some children nodes, tagged underneath here. So if we have a match of this like generated summary text, then it will go, then it will select those child nodes. And that's what we diagrammed down here. The query comes in, it figures out, what's the most related generated summary text, and then there are the original nodes that are then queried from there. Okay. The other thing that you can see is just how easy it is to implement these different strategies. So like we literally just choose different kinds of indices, and then so you can start to. It's like a good way to figure out what are the best. Which one you should be using, right? Is by trying it out. Like I actually like you can. Like this can be, you can think of this as pretty good for like more hierarchical data, like org chart, or like things that maybe would be about like specific companies, and then for each specific company it had like things like that actually fit in terms of an outline. But like a good way, you can do further research on this, and then also just try it out and see how it changes your results. Right, is a good thing to do. All right. Questions about this like indexing. Then from the index, everything is the same. It's just tree index as query engine. That returns a query engine. Then you ask, the query from here. Query engine.query. Get back the response. How did this feel? Yeah? Okay. Let me see if there's a question. Okay, this is about side. Hold on. But I was wondering, how does the Llama index come with tools to create a recommendation engine? For example, if we wanted to recommend books, we can embed books to find books within the same genre. But then we could also look at Amazon reviews or Goodreads to recommend similar books that are highly recommended. My understanding of embeddings is that we shouldn't embed a rating with the text, but it should be done separately. Let me show you. Let me see. If we look at the.
I didn't want to get too outside the scope, but I was just wondering if this is possible with the library index, or if you're incorporating other libraries or technologies.
Yeah, what you can do, it kind of depends on here's kind of let me just frame your question. If you want to do something like, say, here you have like a Goodreads score of 4.5, and you also have and you also have then the text of the book. This is a great book. You can store this as metadata, and then what you can do is basically filter on the metadata and say, hey, let's only get things that have this text, that have this score or higher, and about crime or whatever, right? And are also about crime. Okay. In the readings, and I started asking myself the same question. So I put in, if you go to this what next thing, you'll see that different databases actually implement this differently. So I gave some examples of how to do this with Pinecone, which is one kind of vector database, and then Weaviate, which is another. Okay, so I do think that would be like a really interesting project, right? And I think that's something that you all can do.
Do the vector databases all come with some sort of ability to store the embedding and then metadata that can be used to kind of create different algorithms to get the result you want?
Exactly. Yeah.
Okay.
Yeah. So you can start to see that, right, with this kind of thing, that first you apply this filter that says, okay, this is a double jeopardy type question, and then from there you ask the question. You go further with your text search. Right, so these readings, we'll get into that. The next things, I think that you'll be able to see that this is pretty, just to quickly show this, is then the query itself, right? We talked about storage. The next thing is then queries. So they're different. There's just the simple thing, which is what we've been doing, which is taking a query from the user and simply, performing a similarity score. But then you might think about producing subqueries from the original query. So for example, I provided my original question, which is explain the cause of World War I, include information on the Balkans, overlapping alliances, and the growth of Germany. All right. If you just ask that question and then you perform a similarity score, think about what types of documents or what chunks are going to be returned for you. What's going to be returned is a sentence or a paragraph that covers all three of these, right? Like what kind of sentence is that? It's probably like something at the very beginning of the Wikipedia entry. And even if you include, multiple different documents in a lot of different books, you're still going to get those like summary intro uh, type chunks of data that are going to be returned to you and fed to your LLM. All right. Maybe that's not what you want, because maybe instead what you want is some in-depth information on the Balkans, in-depth information on overlapping alliances, in-depth information on the growth of Germany, right? And then to separately query these three topics and feed that to the LLM. So that's what like subqueries would do, right? It is here you can see. I just say like I literally put this question into the LLM. Please explain the causes, include information about the Balkans, overlapping alliances, growth of Germany. And then what did it do? What were the causes of World War One related to the Balkans? What were the causes of overlapping alliances? How did the growth of Germany? So I didn't specify these questions. All I did was specify the original, and then I said I wanted to use the subquery option. It generated these questions for me, and it produced these answers. Did separate queries of my documents, generated the answers, and then it would synthesize this answer into the final question. You can see that if you look at the logs, that first it generates the query, and then for each sub question, it retrieves the related data, synthesize, retrieves the related data, synthesize, retrieves the related data, synthesize. Even if you ask like a generic question that doesn't, explain the subpoints, it will generate them for you, right? And then do the same thing. Okay, and then I show how to implement it. It's not so difficult. The code implements it for you, so you can see that. All right, that's one thing. And then this hybrid search thing, this is a little harder to understand. We can talk about that separately, but I'll first deploy the readings on this, and then we can come back and talk about like a hybrid search strategy. Is it possible to use a different distance calculation when returning results to use as context? For example, we could use k-means clustering to return context from I don't know about k-means clustering, but you can use, we're using, I think, cosine similarity, but in the query engine, you can specify different metrics to use. So for instance, there's like dot product similarity, I believe, is a separate one. So there's different kinds of metrics that you can use. And you can just Google that. I'm sure you can find some documentation on that. But I don't know. The k-means clustering is interesting, and I'm just not sure about that. But that's a good question to kind of research. Cool. Let me see. I think if you clustered results in this context, you might only get particular quality. I mean, one thing to keep in mind in terms of clustering is that, right, it is kind of clustering. You know what I mean? It's produced, like the way that a search works in general is, if you think about it, let me go back to the concept, is that we're finding clustering does its own, we're clustering close to the query, right? We're finding distance to the query. There is, we're finding like what's so similar from this to our various documents. There is something else, which sounds like what you're starting to talk about, David, and maybe Miles, is something called a knowledge graph. I also provided some, if you want to look into that, I provided some resources on knowledge graphs too, which is, again, like a little bit more advanced. But if you're looking, if you want to look at that, I put it in here as like some bonus material. Okay, so you can look at this stuff too. And I think that's starting, if you look at it, I think this is starting to get to what you're talking about, potentially. We'll see. All right, so for now, indexing data, subqueries, so this hybrid search thing you can take, read through, and I can talk about it later. And then I'm happy to deploy this too. This is the Streamlit LLM. which just shows, I did this for you. I built like a little Streamlit application for you. I wanted to just show how you can do it, and then I'm happy to walk you through it once I put this up here a little bit later. All right. Oh, it's just private. I'll make it public. And then I put in the all right. So let me share my screen. There's basically like two components of it, right? So there's the dashboard, and then there's what I just called it the LLM. Probably should call it something better. But just to take a look at it, this part is very similar to what you've seen before, right? This is a very simple LLM pipeline, right? Like read the data, right, from the PDFs, then turn it into documents, right, with this .load data, vectorize it. We're just using the vanilla vectorizer, and we know that this does a lot of things, right? Meaning that, just remember, like creates the index, does the doc store, and also does the embeddings. So you can think about different embeddings or different index to use, right? We saw the tree index, keyword, right? You can think about a different storage, right? Which would be like a different vector database. I think one of the readings gave an example. I think the hybrid one showed an example of using a different vector database, but you can, like Pinecone is an example. There are some others. Weaviate. You can look at, and then the embeddings are, right, it will also embed it. And then we did the persist data, right? We saw this before. This index, as you kind of note, right, this index has, they're stored as different objects, but remember we did object relations in Python? You do index.storage context, and that will return to you the data store, basically, like where this data is stored. And then we do .persist location to actually save this to disk. And notice that for me, I'm saving it outside of this folder, right, in storage. That way the dashboard can pick up this data store. A few of you asked about saving this to AWS. I mean, I haven't tried it, but I don't see why you can't read this. This is just JSON data, right, the storage. Oopsies, why did I do that? Code /storage. I don't, it's just JSON files, so I don't see why we can't pd.read, use AWS Wrangler to read this storage, and then use AWS Wrangler to write this to S3, right? And then the next person can just read it and write it from S3, right? I don't. You probably can just do that. I'm not sure. Maybe there might be a good reason for not doing that, but as long as you're consistent with it, as long as you remember to save it to S3, that would work fine. The other thing is, probably more likely is there's the same way that we just connect to our RDS database by putting through by having a cloud database host our Postgres. Right, we can have a cloud database host or vector database and just put in, the endpoint, right, the URL where that database lives, etc. That's something. If you look at Pinecone, that's what that will be doing, right? So you can just read and write your data directly to Pinecone, and that will work too. Okay, and then once you save the data, then this function just loads it, right? So storage context from defaults mean keep all the same defaults, whatever they are, and then this is where that directory lives, is in storage, and now load index from that storage context, right, which points to this is where our data is. And then if you look at the setup DB, right, this just loads the data, right, that does the whole read the data in, vectorize it, blah, blah, and then persist it, right, save it to disk. Okay, then from there, the Streamlit app can read this, right? Can basically use this load from DB to read in the index, create a query engine, and when someone submits a question, ask questions of it. Before we get to Streamlit, one thing just to point out is, in this case we have essentially static data, right? Meaning that, right, everything is in this uh, data folder. But you can imagine, think about like our prefect pipeline of how we would, consistently read in additional data. So that, I don't know, like this could be news articles where you're like charting news events over time, right? Maybe you could think of like today, like election data or, any of the international stuff that's going on, right? Like using that updating data to like extract insights or extract even like, numerical data from it, and plot storing that. Right, so you could think of doing something like that, so that you can like set up a prefect pipeline, and then dump data into here, and then you would read the recent data. Like, how do you know that it's recent? Well, we can create a new just same thing. We partition it, create a folder based on the date that the data is pulled from, and then just read the data after a certain date, right? That way you're not repeating, the processing over the same data. So that's the idea. Is like you can you have a prefect pipeline or just some sort of pipeline that reads data into here, and then we process it and load it to the database. Then Streamlit comes in. The most complicated thing so that's our dashboard. What I did just to show you like how this works is I put a breakpoint right here. Okay? So this is in the chat bot. Right, when you can see that it says this chat input is your question, and then this creates a message, and then we do st.sessionState.messages. Let's take a look at this. Okay. I'll go. I'm gonna run this and just show you one thing, and then we can go through it step by step. So Streamlit run app.py. Okay. So I think this should boot up. Yeah, so we can see this part is starting. Ask me a question about Uber or Lyft. Okay, so what was Uber's revenue in 2021? Question. So I press enter here. When I press enter, that's going to have an input here. You see that this says, when I delete this, it says your question. That's this chat input. Your question, right? This is the text. When someone submits a question, that will assign a value to prompt. All right. So I'll say, what was Uber's revenue in 2021? The role is user. Where I'm like, I could have called this anything, but we're saying it makes sense to call this the user. This operator is confusing. It's even more confusing to get into. It's not that confusing, but it's confusing to get into why this is needed, actually. Let's hold off on that. Let's hold off on that for now. We can get into that in a second. So basically, when this is inputted, right, we'll assign the prompt, and then we'll create this message that says, okay, this message came from the user, as opposed to like a response from our LLM. And then we submitted, we got this prompt. And now we'll just add this prompt here. So this is acting like our database, essentially. So we say, like, what is Uber's revenue? Press this. Now if I go here, this hits my breakpoint. Okay? So the main thing is this session state thing. And I just wanted to point out, this session state is just like a data store. Remember we had this store way back in like Python, object-oriented programming stuff? And then we just stored stuff to a dictionary. Session state is the same thing. Okay, so it's just, if I do st.sessionState, I can put anything I want here. Like I can do like foo equals, something, right? And then I do st.sessionState.foo, there's something, right? And then I can do like, this is a dictionary, so we can append, I just appended an empty string accidentally to it, and then I can retrieve it. Right? So that's what I'm doing here, is someone submits a prompt, and I'm just assigning a message. I'm just saying, okay, I'm going to add this dictionary to this. So you can kind of see that the message is from the user. And then if you look at st.sessionState.messages, right now there's only one message, which is the assistance message, which was ask me a question about Uber or Lyft in 2021. How did we get that? It's from like one of these setup prompts. Okay, so I'll show you that in a second. So that's the idea, is just that like this is not anything magical. This session state thing, it's just a place to store data. All right, you can store anything here, but I'm just creating like a key essentially of messages and adding a message to it. So now let's take a step back. If you look at we'll do assign chat message, right? So what does that do? Basically it says, hey, if we have not yet done like st.sessionState.chatEngine, right? Then that means I want you to initialize a new chat engine. So load from DB, what does that do? It basically just loads in the database from storage, or it loads in my index, right, from storage, just using that same method we saw back on the LLM side. So load from DB, and then that's an assigned chat message. Sorry about this. So assign chat message. If we have not yet already set up a chat engine, meaning we haven't done this .chat engine equals thing, then I want you to load in my index, right? Load from what we've stored in storage into an index, and to do index.asQueryEngine. So this is my query engine, right? Because I can do index.asQueryEngine. That comes from Llama Index. Then I store that query engine on this session state thing. Okay? So I do st.sessionState.chatEngine equals this query engine thing. All right? So that's the first piece of setup I do. Is step one, assign the chat engine, and that involves loading in my index and then storing that chat engine of that from there. Then the next thing I call is assign the messages. What does that do? It says it creates an initial piece of content that we want, and then I basically say, hey, if I have not yet set up messages on session state, do it now, right? If messages is not in session state.keys, then create it, right? Set up messages and say this comes from my little LLM bot, and assign the content as this initial piece of content. Okay. So chat engine is not a required key name for a query engine object. We can name it whatever. Narapati, that's correct, right? So I had that same question because I adapted this code from a tutorial, and yeah, this is not, chat engine is not anything special. We called this foobar and said, okay, if foobar is not in here, right, then just store this query engine onto this key. This is just a key value store. That's it. Okay. I like it going forward. I would probably call this query engine because that's what this is. Then think about what happens when what happens next. Set title. All this does is this does nothing fancy. It just sets some text at the top, and this sets like some sort of sidebar, and then it has the title, chat with Uber or Lyft docs, chat with Uber or Lyft docs. That's all that does. Uber and Lyft 10K chatbot. Page title is Uber and Lyft 10-page chatbot. Then the next thing that happens is display chatbox. Let's go to the submit prompt. Let's go back here just because I think this is where we were. Submit prompt and display. If you go to here, the submit prompt. Oh, sorry, I wanted to do this one. Display the chatbot. So now let's take a look at this again. Right, this is the prompt. That creates this thing right here. And then again, we just append in the messages, and we already set up the first one back here, as where we assign the message, and now we're doing another one, where whenever someone presses enter, we add in another message. Okay. Then up top here, we display the message history. So it's like, let's do continue. Okay, so this is what was Uber's revenue. And this says Uber's revenue in 2021 was this. How did we do this part? So if we go to, I think it's here. Is it here? No, it's this one. Submit prompt and display result. Okay. So in submit prompt and display result, what do? We basically say like, hey, someone submitted their message, right? They press enter. If that message did not come from the assistant, meaning if instead it came from the user, right? If this was a user's question, what I want you to do, I want you to submit that question, right? The prompt to the to my query engine, to Llama Index, right? We already stored. Remember, we stored the query engine as this, on this chat engine attribute. So this is the query index dot query the prompt. Okay, we get back the answer. This is the response, and write out the response dot response. Okay, and I want to store that response in my list of messages. Right. So the messages is both, the user question and the assistant's output. All right, and now in the history, all we do is go through each of those, assistant and like the user and chatbots messages, go through each one of them and display it, and show, here's the little, if it's a user, show this guy, and then show their message. So this is the assistant's message, this is the user's message, this is the assistant's message. Okay, let's just take a look at this again. Assign chat engine, what does that do? That just reads in the index and assigns the query engine to be chat engine, right? Assign messages, what does that do? That says my first message is going to be, ask me a question about Uber or Lyft in 2021, right? So that's our initial setup thing. Set up the chat engine, assign the messages. What comes next? Set the title. All that does is sets up some, the page title, some initial chat with Uber or Lyft, write some text on the page. What's next? Display the chat box and store questions. Let's take a look at that. Display, so this just is my actual prompt thing right here. And then when someone presses enter, it creates a new question or a message that we just store here. That way we can display it in our history. What comes next? Display the message history, right? So that's all this stuff right here. Let's take a look at that. Display message history, just go through each one of the messages that we stored. Show, have a little icon for the role, right? User or assistant. I guess that probably does need to be a keyword of user or assistant, because it corresponds with like a little icon thing, and then the actual content right after it. Okay, and we can see that's in here. And then what comes after that? Submit the prompt and display result. Let's take a look at that. So then here's where, when that prompt comes in, so someone submits their prompt, they press return, Streamlit will kind of rerun this. So they submit the prompt, the history will be displayed, so that will be like their answer, or their question will be displayed, and then the submit prompt will display a result that takes in the prompt that the user put in the little chat thing when they press enter. Then we take in that prompt, and we're going to pass that prompt to our query engine. So that's this submit the prompt and display result. If that message was from the user, right, then I want you to submit it to the query engine, right, which we get from the session state.chat engine thing, query it, get back the response, and write out that response. All right, so this is the code. Like I said, I borrowed this from a like from a tutorial and adapted it and like broke it up and things like that. But this is a pretty good layout for how to produce one of these things. All right, we can go through this part here. This just means you can assign something, right? It's like you can do like if instead of doing like length of users, say this is like the number of users, you can do this, number of users equals, and then you say if number of users is greater than 10, then say a lot of users. So this is like 2 lines of code. What you can do with the colon equals is break this into uh, multiple line. It put this condense this into one line of code where you do colon equals like this, I believe. So now we're both assigning the length of users to be number of users inside my if condition. Why is that necessary here? I'm not sure. Other than that, I tried removing this and it broke. It like threw off stuff. But I have to think harder. My brain has to get smarter for me to figure out why it's breaking without this logic right here. I'm not quite sure, but I just know that I tried it without it and it broke. So I'm not sure. All right. Hopefully, though, you kind of understand how you can build a pipeline and then how you can, turn this into like a Streamlit app that reads from your data store. One other thing, I guess maybe two other things, is look at the. I know don't worry, we'll break in like 1 second. Is just look at the next steps type thing. One thing that's interesting, right, is this like kind of combining like SQL-like queries with these like Llama index, right, vector store queries. And I gave you different examples as things you can do here. Another kind of that's one thing, right, is like thinking of these projects. The other thing that's interesting is this output parsing. I think this is really interesting, right, because a really good use case of using, OpenAI, these various LLMs, is taking unstructured data and turning it into structured data. Why is that useful? Well, like we still like SQL. It's still a lot faster to run SQL, and it's good to be able to run these very hard queries of like, what are the number? Like if you think about, I was thinking about like what if we scrape data, right? All these job postings. Like data engineering jobs. And then, it'll be great out of those job postings to be able to parse, okay, what's the salary from each posting? What's the skills requested? Is this a junior or senior? How many years, right? What an LLM can do is required, right? What an LLM can do is take unstructured text and pull it into structured text, right? And say, okay, this row is John, this is his age. This is, the city I think he lives in, right? So turning our unstructured data into structured data is extremely useful, right? For then doing analytics, for then writing proper SQL queries and getting essentially what we want out of it, building a dashboard, right? So like that's another good thing for like a project to do is pull out data, right? You can think about financial data inside these 10Ks. Can we pull out that kind of information, pull it into structured data, load it into a Postgres database, something like that, right? So these are all good projects and things to explore. All right, after